So absolute values is one of the last sections we have for this week. And so absolute values, most people know absolute value is a distance from a point from zero. We're going to look a little bit more at it than that. So we're going to expand this a bit. So just in general, an absolute value is denoted with these, what we call absolute value bars. Write that there. So it's called an absolute value bar. I believe I had mentioned that earlier when I was talking about groupings. But how it is defined is that if x is positive, and we plug it in here, what it's saying is that if x is positive, then we're going to put in the absolute value bars, and it's going to stay positive. If, in this case, let me write this in red so we can see it's different. This is x is less than 0, x is negative. If we put in the absolute value bars, then we put this negative on it because basically we're changing this into a positive number. So just to go back here, this also works. If x is 0, then it should stay 0 over here. So in other words, what an absolute value does is it just takes a number and it presents it as its positive version. So the absolute value of 3 is 3. The absolute value of negative 3 is also 3. Okay, so properties of absolute values. So we've got to be careful when we have absolute values that what we're getting back out, we want to make sure it stays positive. So if we have two numbers multiplied together in absolute values, well, the way we can rewrite that is if it's absolute value of A and B is the absolute value of A times the absolute value of B. So you've got to be really careful with your absolute values. If you have a quotient, absolute value of A over B, that's the same as absolute value of A over absolute value of B. And if I have the absolute value of negative A is the same as the absolute value of positive A. So basically it's just saying this. This should always be equal. So you got to be careful, like I said, with absolute values. So if I have x times y, I have to make sure that I write it as x times y. However, if I had 3 times y, this is a little different. I can drop the absolute value off that 3 because I know it's just going to be 3. The y, I do not know what it is, so I have to keep the absolute value on anything that is a variable. So it's usually where I see a mistake is that we think we can drop those absolute value bars when we can't. So we are going to simplify these. And we're going to leave as little as possible inside the absolute value signs. So this would be part of simplifying is just trying to get rid of absolute value signs when we can. So if I have absolute value of 7 times x, that's the absolute value of 7 times the absolute value of x. I know the absolute value of 7 stays 7. I don't know about x though, so I just keep those absolute value bars around x. So like I said, you just have to keep them around the variable. And the reason we do that is, like I said, I don't know what x is. X could be -3, so I can't say it's just going to be 7x because then it's going to end up giving me a negative answer. So we keep them around the variables. If I have absolute value of -8y, well, it's the absolute value of -8 times the absolute value of y. We know the absolute value of -8 is just 8, so that just becomes 8 absolute value of y. All right, so squares are a little different. So if you remember, if I had 3 squared, that gives me 9. If I have a -3 and I square it, I get a +9. So what that means is that if I take any number and I square it, the result is going to be positive. So what I have here in the case of C is that absolute value of 6 times the absolute value of x squared. So, or sorry, we're going to have absolute value of x times absolute value of x squared. 6 days 6. X squared is going to end up being x squared because we know that x squared is going to stay positive. Therefore, I do not need those absolute value bars. So just as a little note here, that absolute value of x squared can always just be rewritten as x squared. It's a case where we can drop it. However, if it's just x, look at this x cubed, I'd have to keep those absolute value bars. And this case is because x cubed, like if I had -1 and I cubed it, would still stay -1. We don't get rid of those negatives when we're cubing. But the negative only disappears when we're doing a square. And our last case is the quotient. So that's absolute value of 8x over the absolute value of -4x squared. And then we can expand that as absolute value of 8 on top times absolute value of x. And then on the bottom, absolute value of -4 times absolute value of x squared. So 8 will stay 8. I have to keep the absolute values around this x because it's just a single x. -4, if I do the absolute value, is just 4. X squared, absolute value is x squared. So in this case, the only absolute value we keep is the one on top. And don't try to cancel out x's here because this was an absolute value and this one isn't. And you kind of can do it, but it's just going to be a little complicated. Okay, so just to show you about what would happen if you're trying to simplify. So this one, d, we said it ought to be 2 over the square root of x. So that was because we got down to here. So what happens is that if you eliminate that x, what happens is that this one's gone and then this x down here is gone. So now we have to bring back those absolute value bars to make sure that x still stays positive. So I actually did this a more complicated way just so we can get through the rules. So I just want to point out you also could have simplified the square root, sorry, everything inside the absolute value bars first. So they simplified this and got left with the 2, simplified this with a -x. And then we know that the absolute value of -x is just equal to the absolute value of x. So it's just an alternate way to do it. And made a mistake here. So these are the ones where on your worksheet, I accidentally just duplicated those. So you get a freebie on this one.